All right, so we're going to talk a little bit about a math grammar type thing that is talking about not allowing a irrational denominator. Now it's just poor math grammar. Just you have to kind of accept that. It's the way it goes. So here we go. So 11 over 3, we have the square root of 11 over 3. Now the square root of 11 over 3 can be written as the square root of 11 over the square root of 3. And 11 and 3, they do not share any common factors. So I can't hope to cancel things out and not have a square root in the denominator. So since that's the case, I need to make sure that both of the numbers are in simplest radical form, which they are, because 11 doesn't have any perfect square factors. 3 doesn't have any perfect square factors. Perfect square factor, again, is like 4, 9, 16, 25, 100, 144. So what could I do? What could I multiply both the numerator and the denominator by that would make the square root of 3 a rational number, a number without a square root? Well, the square root of 3 times the square root of 3, well, that would give me 3, wouldn't it? But when I multiply the denominator by, I also must multiply the numerator by. Square root of 11 times square root of 3 is the square root of 33. Now, the one thing I do need to look out for is, can the square root of 33 be reduced in any way? And the answer is no, it can't, because 33 does not have any perfect square factors. All right, same idea for the next one. Square root of 2 over the square root of 5. And obviously I just applied the square root to both the numerator and the denominator. No big deal. All right, so what can I multiply the denominator by that would rationalize the denominator, make it a rational number? Well, if I follow the lead on this one, if I multiply the denominator by itself, if I square the denominator, when I do the denominator, I have to do the numerator. So I'll get the square root of 10 over square root of 25, which is just 5. Now, I know many of you would be tempted to say, okay, the square root of 2 times the square root of 5 over 5, and then cancel these out. This is a big no, you can't do that, because this is the square root of 5, and that is 5. They are not the same thing. So we're just kind of done with this piece. This problem is slightly different when we're trying to rationalize the denominator, because this is equal to the square root of 19 over the square root of 8. But the square root of 8, well, we can simplify this further, because the square root of 8 is equal to the square root of 4 times the square root of 2. And the square root of 4, well, that's just a rational number, too. So really, we have the square root of 19 over 2 times the square root of 2. So see how it's a little bit different, but not fundamentally different. What can I multiply the square root of 2 by that would get rid of that denominator, that irrational part of the denominator? Well, I can multiply by the square root of 2. When I do the numerator, I have to do the denominator. So square root of 2 times the square root of 2 is 4. Sorry, square root of 2 divided by square root of 2 times the square root of 2 is square root of 4. And the square root of 4 is 2. So we have square root of 19 in the numerator, and we have 2 times 2, which is 4 in the denominator. And we still have the square root of 19 in the numerator. So this was a quick little crash course on how to rationalize a denominator.